Hello. Alright, so let's go ahead and solve this first order differential equation. As always, I'm going to rewrite this as dy by dx minus 3y. I just replaced this with this notation. It's way more convenient for the work we're trying to do. Okay, so again, just to reiterate, what I'm trying to do is trying to get all the dx's and dy's separate sides. So dy's and y's on one side and dx's and x's on the other side. So we're doing that so that we can take the integral with respect to all of them and with respect to all of them later on. Right? Okay. So now I'm just going to multiply. I'm just going to move all these. I'm going to move this 2 to the right and multiply by dx. So I have dy minus 3y plus dy by dx minus 2. I get dy minus 3y okay. Now I'm going to do it's going to be dy equals minus 2 dx minus 3y dx. Sorry, plus 3y dx. And then I'm going to pull this dx term out. Right, so we get dy equals minus 2 plus 3y times dx. Okay, and then bring this whole thing down here, so we get 1 over minus 2 plus 3y dy equals 1 dx. Okay, great. Now we're in a position to take the integral of both sides. Should have left some more space out here, but the idea is this, right? Take the integral of both sides. Okay, and this is pretty straightforward. Right? So this is pretty trivial. This becomes just x plus c, right? The integral of 1, the antiderivative. Okay. Now this is a bit trickier. So now we have to do some separate integration steps for this. Okay. So what is the integral of 1 over minus 2 plus 3y dy? Okay, so generally I try to work through these as first thing I'm going to try substitution, because that's generally the easiest thing to do instead of before we try integration by parts, right, or trig substitution. So let's try by see if substitution will work here, right? So you can see that if we take this bottom, the denominator 2 equals u, once we derive it, this y term will disappear, and that's fine, because then we have du equals some dy, and there's no y term up here, so that might work. So let's go ahead and try that. Okay, so let u equals u equals minus 2 plus 3y. Okay, now du will equal, well, this goes to 0, this goes to 0, and then this is just 1, and this is 3 dy. Okay, and then 3 equals dy. Alright. Okay, so now we can substitute this back in. So I'm just going to take this up here so we have no space. So we're going to substitute this back into this equation, right? So just colors. I'm going to take this, take this part and this part, and substitute it back into this equation. Okay. And that gives us the integral of so the integral of y, so the integral of 1 over, actually I'm just pick 1 over, and then plugging this back in, right, plugging this back in, so 1 over u times dy is now du over 3, so du over 3. So what's that? So we can pull this 1/3 outside. This is going to be the integral. This is going to be 1/3 times the integral of 1 over u du, which is going to be the integral of 1 over u is the natural log. So it's going to be 1/3 times the log absolute value of u plus c. And then we bring this back. So we're going to take these components and plug it back in here, right? So because we know that u equals this quantity, so this equals 1/3 natural log of the absolute value of -2 plus 3y plus c. Okay, so now we can combine these two parts together, right? The left and the right hand side of these two equations, and then we get the following. We get, so the left hand side, the integral becomes this thing, so it's 1/3 the natural log of -2 plus 3y plus c equals x plus c. Okay. All right. So this becomes, this whole thing becomes left hand side, and then this is the right hand side. It's brought it back here. Okay. Now we can just eliminate one. Just combine these two c's into one because they're just two arbitrary constants. So x1 plus c will do. Okay. Next, what we're going to do is we have to solve for this y term. So how can we do that? Well, first of all, let's just multiply this through by 3, so that gives us natural log of 3y minus 2 plus 3y equals 3x plus c. Remember, multiplying arbitrary constant by some constant is still not the arbitrary constant. Okay. Now, because we have a log on this side, let's take the exponent. So this we have. So what we get when we take an exponent of a logarithm, we get whatever's inside, right? So this is just the absolute value of -2 plus 3y, which equals e. Taking e of both sides, e to the 3x plus c. Okay, great. Now we have to solve for this y value. Okay. Now what we're going to do is we're going to recognize that we can rewrite this term. We can rewrite this as y equals e to the 3x times e to the c. This is just a rule of exponents. So if you have some base plus with a sum in the exponent or minus, you can do it in this way. Okay. All right. So now we can do is we need to incorporate this absolute value somehow. So what this is saying is that no matter what value this inside these terms inside take, the positive value of the positive value of whatever's inside is defined by this equation. So basically what we're saying in this situation is this. So y can be positive or negative. No matter what happens, we're still going to get a positive answer from this. Right? So e to the 3x plus c is always going to be positive. Right? So by understanding that, we can incorporate this plus minus situation into this e to the c constants, right? So what we can do is we can say minus 2 plus 3y equals d, some value d times e to the times e to the 3x, and 3y equals d e to 3x plus 2, and y equals d e to the 3x over 3 plus 2 over 3. Okay. So basically, if you look at this and you say if d is some number such that this y evaluates to be some number, and then that number ends up becoming negative inside this, it's still going to be positive because of the absolute value, and that's fine. If it becomes positive on the inside, it's still going to be absolute value, so that the equality still holds. Okay, so that's the basic idea. Now that we have this y function, we have the initial value, we can solve for what the d value is. So we know that y of 2 is 1, which means you plug in 1 for it. So y is 1. Sorry, yeah, y is 1 when x is 2. So d e to the 3 times 2 over 3 plus 2/3. And if you multiply this out by 3, we get 3 equals d e to the 6 plus 2. And this is, so if we solve this, we get 1 equals d e to the 6. And from there we get d is 1 over e to the 6.